Alright, so right now we are on standard 4 kinematics, and this is a rerun, a new attempt, I guess. Alright, so first of all, we have Robin Hood on this elevated surface, okay? We don't know the height. We're given the initial velocity and the final time. Okay, so the initial velocity is 45 meters per second. Final time is 5.2 seconds it takes. So we have to figure out what is the velocity when the arrow strikes the ground. Okay. So Robin Hood shoots it at the initial velocity. Okay. Shoots his arrow. It falls down. Okay. We need to figure out this. What is the final velocity? Okay. Well, first of all, we have to find the height. But to kind of figure things out, I did the initial and final. Took what we knew. So we knew the initial was 45 meters per second. We knew the forces of gravity was working on it in a negative direction. We didn't know how many seconds. Well, at first it's going to be 0 seconds, okay? That makes sense. It's going to be 0, okay? And right here, we were solving for this. I circled this, VF. The final for the forces is same thing, negative 9.8, because it's constant. And then the final is 5.2 seconds. So I took what we were given, put it in initial and final terms, and kind of figured out what we needed to solve for. Okay, I try to keep it simple. So right here, question mark, what is your final? Okay, on your velocity. So I used this formula. Initial minus final, or minus initial, whatever way. Okay, equals the velocity. And so I did was a time plus 1/2. Force is actually 9.81 seconds squared, 5.2 squared. Okay, that canceled. So I got, okay, for a height, because we first had to solve for the height, 133 meters tall. That's how high the elevated surface was. Okay, so we figured out the height, 133 meters. Now that's just using this formula. Okay, basic algebra to this. Okay, now I use this formula. So I took what we were given. Alright, I use this formula equals the initial at the acceleration and the time. Okay, so what I did right here was I just took your VFX and your VFY, okay? That relates up here to your X and Y axis. I took 45 would be my X, 0 would be the Y, and then negative 9.8 times 5.2 seconds, okay? I wound up with, multiply those two, you're going to get 51, okay, negative 51. And then to figure this out, I just took Pythagorean theorem, okay, and I got 68 meters per second, and that would be the velocity it took, the amount of velocity it took when it strikes the ground. So that's the amount. So 68 meters per second is the amount of velocity it takes when it hits the ground. Thank you. Bye.